Before we start writing code, we have to go over the HTTP protocol and the architecture of our server. We will be implementing an HTTP 1.1 server, and HTTP 1.1 is an application layer protocol or layer 7 protocol, and it is sent over TCP. Clients and servers communicate by exchanging individual messages instead of streaming data. The messages sent by the client, which is usually a web browser, are called requests, and the messages sent by the server as an answer are called responses. Here we have an HTTP request and a corresponding response. The request starts with a method. This can be get, post, put, connect. There are 9 HTTP methods overall, and we'll go over them in detail later. The method is followed by the path. The path might also contain a query string, but it's not necessary. And this is followed by the protocol version. Our server will work with HTTP 1.1. The protocol is followed by a new line, and then a list of the request headers. The headers are in a key value format and are separated by new lines. At the end of the headers, there are always 2 new lines that are followed by the body of the request. In this case, the request body is empty. If we look at the response now, we see that it starts with the protocol. This is followed by the status code and the reason phrase. There are many possible status codes like 200 OK or 404 not found, for example. This line is also followed by a list of headers, and the headers are followed by 2 new lines and the response body. The body can be anything, the contents of an HTML or JavaScript or CSS file. It can be JSON or any other data format. Because our main focus is on learning Rust and not so much on building a production-ready web server, our implementation of HTTP will focus on certain parts of the request and the response. Most notably, we will ignore the headers in both the request and the response. This means that we will have to handle the HTTP method, the path, the query string, and the protocol in the request, and the protocol status code, the reason phrase, and the body in the response. Let's see how our server will look like. It will have 3 main components. As we said, HTTP is transferred over TCP, so we need the ability to listen for new TCP connections and read and write bytes from those connections. To do that, we would need a TCP listener. Once we read some bytes from the incoming connection, we have to parse them into useful HTTP data structures. For this, we need to implement an HTTP parser, and this is where most of the code will go. Once we successfully parse the incoming HTTP request, we'll pass it on to a request handler. This handler will have some routing logic that will execute different code or return different files based on the HTTP method and path. Then the handler will again use the HTTP implementation to create an HTTP response and will hand it back to the TCP server that will send it back to the client. Important thing to note here is that all of these will run on a single thread, so our server will be handling a single request at a time.